good day, geometry. I'm with you with CO35, using proportions to find angles and sides of similar polygons. This piggybacks off of CO34. My original intention during our live class this week was to do 34 and 35 together because they are so, wait for it, similar. But we got to talk about the math packet and time got away from me. So you get separate lessons for each of them. But we've kind of already talked about everything in CO35. We know what similar figures are. Similar figures are figures, or polygons, be rectangles, pentagons. We're going to kind of focus more on triangles than anything else. But figures with corresponding sides that are proportional. When we talked about congruent figures, those corresponding sides were congruent or equal. Okay. In similar figures, those corresponding sides are proportional. And a scale factor is how much bigger or smaller one figure is compared to the other. And we've talked about scale factors before when using rates and ratios and proportions actually too. But when you say that one figure is twice the size, that's a scale factor of 2. When you say that a figure is a third the size, it's a scale factor of 1/3, whatever it happens to be. Okay, so you have those definitions there for you. And I'm going to scroll down a little bit here, and we're going to answer questions 1, 2, and 3. So get those definitions down, pause the video if you need some more time, and we will scroll on down. Got away from me there. There we go. So answer the questions about the figures at the right. So here we have triangle TRS and triangle ZXY. And it says, write the ratios of corresponding sides. Are the triangles similar? So I'm going to label, going to identify the corresponding sides with both colors and ratios here. So we have 25 and 15 is one ratio of sides. We have 20 and 12, they correspond. And then we have 30 and 18. Okay, and what we're looking for here is, are these triangles similar? And if they're similar, then they're all going to be proportional. So whether we look at all the corresponding sides are going to be proportional. So whether we look at these corresponding sides as ratios, if I have them here, or we could write them as fractions also. Here's 25/15. This would be 20/12. This would be 30/18. Are all of these fractions equivalent? Well, 25/15 reduces to be 5/3, dividing both by 5. 20/12, if we divide by 4, gives us 5/3. And 30/18, if we divide both by 6, gives us 5/3. So because all of these are equivalent values, are the triangles similar? Yes. Okay, because those corresponding sides all have the same proportional relationship. And then what is the scale factor for the figures? Well, how do we get from one figure to the other? Okay, triangle TRS is 5/3 the size of triangle ZXY. Okay, or we could also say, if we start with triangle ZXY, that being the smaller triangle ZXY is 3/5 the size of triangle TRS. So it kind of depends on which one that you start with. If you're starting with the smaller one, it's 3/5 the size. If you start with a larger one, it's 5/3 the size. Both are acceptable to say. You just need to make sure that you're being clear with which triangle you are starting with. Okay. Do the perimeters of the triangles have this same scale factor? Show how you know. Number 3 here. Well, in triangle TRS, we've got a perimeter of 20 plus 25 plus 30, okay, which equals 75. And then in triangle, my mind wants to write X, Y, Z, but keeping them corresponding sides, ZXY, we have a perimeter of 12 plus 15 plus 18, which is 27, 54. Okay. No, 45. Where do you get 54 from? 45. And if we divide each of these by 15, this fraction does simplify to be 5/3. So does the perimeter have the same, do the perimeters have the same scale factors as those pairs of corresponding sides? The answer is yes. Okay, and that brings us to the perimeters of similar polygons theorem, 6.3. This says that the perimeters of similar figures will have the same scale factor as those corresponding sides. Okay. So similar figures with proportional sides will also have proportional perimeters with the same scale factor. And it turns out, I'm going to scroll down here just a little bit here, but it turns out that any corresponding segments within corresponding triangles will also be proportional with that same scale factor. And we see that down here in the example here. Triangle TPR, which is a smaller triangle on the left there, compared to triangle XPZ. This symbol here, I missed it. How do I miss it? This symbol here, there we go. That means that triangles are, excuse me, similar. Okay, that means that triangles are similar. The congruency statement is, well, similar to that, but it's an equal sign with that over it, that wavy line over it. Here it's just the wavy line. That means they are similar. And so knowing that those two triangles are similar, we're looking for PS. Okay, and we've got side TR as 12. We have side XZ as 16. We want to find side PS. So I'll put that as my X, or it's just side PS there, I suppose. And we can compare that with 20 there. Okay, so just like we set up proportions in CO33 or 34, I've got the corresponding sides of my triangles, 12 to 16, set up with the special segments inside here that side PS to 20. 12 is to 16 as PS is to 20. Okay, I start with the same triangle each time, that smaller triangle, 12 to 16, then PS to 20, and corresponding sides. So using cross products to solve this, since that works every single time, we have 12 times 20, which is 240, equals 16 times PS, which I'll just replace that PS with an X. Okay, so 240 equals 16X. You can divide both sides by 16. Pulling out my flip phone to do it accurately here. 240 divided by 16 is 15, and that is our value for PS. Okay. And if we look at these scale factors here, 12 sixteenths equals 3/4. 15 twentieths also equals 3/4. So I plug that 15 in for PS in my proportion, it all checks out. So your homework is just going to be more practice with writing these proportions, solving these proportions, identifying corresponding sides, and setting up your proportion correctly. So what I'd like you to do is on page 376, 9 through 11, 19, 20. Then I'm also going to give you a little bit of review of things that we've talked about before, but maybe not in a little while. 43 through 45. Okay, 43 through 45. This is going to be due next week when we meet for our live classes. As I told the group yesterday and put in yesterday's video, we'll meet Tuesday or Wednesday of next week. We have Monday off, so if a live class, you may come Tuesday or Wednesday after school, and then we'll have a recorded lesson again on Thursday. So short video today, short lesson today. It is just kind of falls right in line with what we did in CO34, and that wraps it up for this week. So that is how you math. Don't forget to like and subscribe, and have a great day.